Okay, YouTube, in my last video we introduced the concept of combinations of functions where we just add, subtract, multiply, or divide two functions. In this video I just want to explore what is the effect of combinations of functions on the graph of two functions, most notably sums of two functions or differences of two functions. So often you'll see situations where you'll be given two functions that are just defined as a graph. So for instance, here we see we have some f of x and it's just this little relation here, and we say g of x is this one here. What we want to do is actually sketch the following combinations of functions. We have a combos of functions. So for instance, when we want to find f of x plus g of x, what would that basically translate to with respect to the graph? So I think that the best way to look at this, and we'll go ahead and do our f plus g of x over here. We're going to sketch that over here. The best thing to do is really look at this in a tabular format. So what we know is essentially this. We have some x values here, and in each of these relationships we use x values 1, 3, 4, and 6. We got 1, 3, 4, and 6. And if we were to fill in our f values, say here, and our g values here, okay? Let's go ahead and do that. We say 1 went to 1 on our first relation here. We said 3 goes to 3. 4 went to 2, so 4, 2 is on that relationship there, and then we have 6, 2 here. We have our xy pairs for f of x. Let's talk about g of x. Its pairs were 1, negative 1, so 1 went to negative 1. We say 3 maps onto 1. We say that 4 maps onto 1, and we say that 6 maps onto negative 1 here. What we're really interested in doing then is saying, let's go find f plus g of x. Okay, that's what we want to go find. So when we say find f plus g of x, we're saying, well then for each respective input, all we're really doing is taking the f values from the first one and adding it to the g value of the second one and getting some new f plus g value. So I notice here that I get 1 plus negative 1 really just comes out to be 0. And if I were to add now f of x plus g of x at the x value 3, we would get 3 plus 1 is 4. 2 plus 1 is 3, and at the x value 6, we get 2 plus negative 1 is 1. So when we go graph these now, we say, what would f plus g of x look like? Really, all we're really doing is saying, let's take the y value here and add it to the y value here, and we get our new y value, which was, in this case, 0. So if we were to graph this, we get 1, 0. We would say 3, 4 is our next point on this combination of functions. We would say that 4, 3 looks like it's on this graph, and then we would say 6, 1. So over 6, up 1. And if we were to connect the dots here, connect it, we would say that that's kind of neat. But this new relationship here is what the graph of f plus g of x would look like, where all we did was just add up the original y values for the original relationship here at each individual x value. So instead of using a table in this next example to find f minus g of x, okay, we're actually just going to go look at this graph over here and say, can I figure out what this would look like? So we have f minus g of x. And so for our x value of 1, we have our f value at 1, f of 1 is 1, minus g of 1 is negative 1. So 1 minus a negative 1, that actually gives us a 1 plus 1, that actually comes out to be 2. Okay? And then we say, how about at the x value 3 here? Well, we got our f of x, f of 3 here is 3, minus g of 3. F of 3 minus g of 3 would be 3 minus 1 is also 2, so we have 3, 2. At the x value 4 here, we've got f of 4 is 2 and g of 4 is 1. So f of 4 minus g of 4 is really the difference in these y values, 2 minus 1. So 2 minus 1 is 1. And then we'd say at the x value 6 here, we take our y value for f minus the y value for g, and we get 2 minus a negative 1 is 2 plus 1. We actually get 3, so 6, 3. So the graph of this relation here would actually be the graph of f minus g of x. Now the last thing I want to do is basically point out that f minus g and g minus f are two separate things, okay? So when we look at g minus f, we're actually going to subtract in a different order. We say, so for the input 1, for the x value of 1 here, we're taking our g of 1 value minus our f of 1 value, which in this case gives us negative 1 minus a positive 1, which is negative 2. So for the input 1, we actually get an output negative 2. If we go over to 3 here, for the input 3, we're taking our g of 3 minus f of 3, which is 1 minus 3, which is negative 2. Okay, so we get negative 2. How about for 4, we get 1 minus 2, which is negative 1, so we get this here. And then for over here, we'd get g of 6 minus f of 6, which is our y value at 6 for g minus a y value at 6 for f here. So negative 1 minus 2 is negative 3. And so we're going to have to use our imagination a little bit here. Actually, no, that fits on the graph. But this relation that we're graphing right here, we would say that this relation is the graph of g minus f of x. And I want everybody to see that it is not the same thing as f minus g of x. Cheers.